Hello everyone, happy to see you here. Welcome back to my channel Higher Mathematics. Today we have a very interesting question. We know that the sum a plus b equal to 6 and a product a times b equal to 36. So we need to find a and b. So if you have your answer, your approach, you can also write it in the comments below and then we will check our answers. So I just want to rewrite this a plus b equal to 6. This is our first step. So we have a plus b equal to 6, and from here we can easily express our b. Okay, so our first step is to express from here our b. So b equal to 6 minus a. B equal to 6 minus a. This is a really important expression, so I want to underline this expression. So b equal to 6 minus a. The next thing we're going to do, we're going to plug in, instead of this b to the second equation, we're going to plug in 6 minus a. So let's do it. I'm gonna do it on the left side right here. So we have a, instead of this b, I'm going to plug in this 6 minus a. So we have times 6 minus a equal to 36. Right now let's simplify this. Let's simplify this expression. So as a result, what do we have? 6a minus a times a minus a square. And I want to write this 36 on the left side, so but with the negative sign. So minus 36 is equal to 0. Right now, I hope you see that this is a quadratic equation. So we have a square, we have a constant, but we really need a different order. So we need to put this expression on the first position. So we have minus x squared. Then I think with a plus 6a and minus 36 is equal to 0. Right now we don't need this negative sign because a lot of students prefer like a classic variation with the a square with the positive sign. So that's why we're going to multiply both sides by minus 1. Okay, so let's do it right now. As a result, we have a square minus 6a and plus 36 and plus 36. This is our quadratic equation. Right now let's solve it. Of course, there are a lot of ways how can we solve it, but I suggest you to solve this question with the basic method of coefficients. This is our method. So we know that a equal to 1, b equal to minus 6, and c equal to 36. We know these coefficients, and right now I want to start with the discriminant. So discriminant equal to b squared minus 4ac. As a result, what do we have? B squared minus 6 squared minus 4 times 1 and times 36. So this is our discriminant. Let's simplify this real quick. So we have 36 minus 4 times 36 equal to 144. 144 equal to minus 108. Minus 108. Yeah, really great. And right now, what can we do from here? We can find our a first and second. Yeah, we know everything about it, so we need to plug in it in all known formula. A first and second equal to minus b plus minus square root of discriminant and all over to a. So let's plug in each of these elements into this formula. So we have minus b minus 6 plus minus square root of discriminant square root of minus 108, yeah, and we divide it by 2a by 2 times 1. Right now let's simplify this expression. So minus 6, this is our positive, this is our 6, yeah, we have 6, plus minus square root of 100 minus 108, yeah, and we divide it by 2. Right now, a few thoughts about this square root of minus 108. I suggest you to do this a quick manipulation with this value like 108. How can we express this? First of all, I want to divide it by 2. We have 54, yeah, 54. I'm going to divide it by 2. We have 27. We can divide it by 3. We have 9. We can divide it by 3. We have 3. And we can divide it by 3, we have 1. So how can we express this? We can express this as 2 squared. Right here we have 2 squared. Right here we have 3 squared. Yes, 3 squared. We have 3 and 1. So this 108 can be written as. So let's do it. Let's continue our simplification. So we have 6 plus minus. We have right here minus. So let's start with square root of minus 1. Yeah, we can easily do this. Or we can do this in that way. We can do this step by step. So we can start with square root of minus 1 times 2 squared from here. Yeah, 2 squared times 3 squared times 3, yeah, times 3, and we divide it by 2, yeah. Right now, what do we have? 6 plus minus, we can easily split it, yeah, we can split it, we can write it as square root of minus 1, yeah, in one square, under one square root sign, times square root of 2 squared times square root of 3 square and times square root of 3. Okay, so I hope you understand it. Right now we can cancel a lot of things from here because we have square root sign. So as a result we have 6 plus minus. Square root of minus 1, this is our I, imaginary unit, this is our I, times square root of 2 square, we can cancel it, we have only 2, times square root of 3 square, we can cancel it, we have only 3, times square root of 3. Yeah, we can't simplify this, square root of 3, and all over 2. Right now, what do we have from here? 6 plus minus 2 times 3, we have 6, so we can write it as 6i square root of 3, 6i square root of 3, and all over 2. And right now, of course, there are a lot of ways how can we simplify this, but we can easily divide it by 2. So we can divide each of these coefficients by 2, and as a result, our final answer, we have 3 plus minus 3i square root of 3. This is our a first and a second. So let's write it. But before solving this, let's rewrite it our expression. Where can we find b? So b equal to 6 minus a. Okay, so from here, I want to underline it that we know a first equal to, let's go with the plus sign, 3 plus 3i square root of 3. This is our a first, yeah, a first. We know everything about a second equal to 3 minus 3i square root of 3, yes. And we know everything about b, so b equal to 6 minus a. So let's write it, b equal to 6 minus a. B equal to 6 minus a. So right now let's find real quick our b first. So let's do it, for example, on the left side. So b first equal to 6 minus a first. A first is right here. So as a result, what do we have? We have b first equal to 6 minus a first. This is our a first. So minus 3 plus 3i square root of 3. Yeah, let's simplify this. So as a result, we have b second equal to b first equal to 6 minus 3. We have 3, and with the negative sign, 3i square root of 3. This is our b first. Yes, really great. And right now, real quick, we're gonna find our b second. So let's do it. For example, b second, let's find right here. So b second equal to 6 minus a second. Yeah, 6 minus a second. So b second equal to 6 minus a second. A second, this one. So 3 minus 3i square root of 3. So as a result, our b second is equal to 3 plus 3i square root of 3. This is our second root. Right now, let's write our final answer. Let's group it in like one line right here, and let's check this root. So our answer, let's start from here because it will be like a long line. So we have answer. Our pairs a and b, we have two roots. First pair, we have a first, b first, a first, b first. So 3 plus 3i square root of 3, and the second root, 3 minus 3i square root of 3, and the second pair, 3 minus 3i square root of 3, and 3 plus 3i square root of 3. Really great. And right now, let's check this root real quick. Okay, we have both pairs, and let's rewrite our question from the beginning. So we had a plus b equal to 6, and ab equal to 36. Right now, let's check these roots. We don't need to check both pairs because we have addition and multiplication. We can easily change positions, and it doesn't matter anything for us because in multiplication division we can easily change position. A plus b, b plus a, and doesn't matter because we have symmetrical pairs. It's not like it with different coefficients. We have absolutely the same thing with the like symmetrical signs, and a multiplication and addition are absolutely symmetrical mathematical operations. Yeah. So let's start, for example, with addition. Let's check addition. So let's use, for example, this parenthesis. So 3 plus 3i square root of 3 plus 3 minus 3i square root of 3, and this one need to be equal to 6. So we can cancel this expression, we can cancel this one. 3 plus 3 equal to 6. So addition, great. Addition, we solved perfectly. Right now, multiplication, a times b equal to 36, and let's use the same expression. So from this parenthesis, so we have 3 plus 3i square root of 3, 3 minus 3i square root of 3, and this one need to be equal to 36. Right now, let's simplify this expression. So we have 36. Right now, let's simplify this expression. First of all, I want to underline really important moment because, if, for example, this is our x, And this is our y, and we have absolutely the same expression right here. This is also x, and this is also our y, but we have different signs. But let's say from a different angle. We have x plus y, x minus y, and from school you should know that there's like a really important formula: x squared minus y squared equal to x plus y, x minus y. And this is exactly our case. This is our difference of two squares, so we need to raise. I'm going to continue. Let's continue right here. So we have difference of squares, 3 square minus 3i square root of 3 to the second power, and equal to 36. Okay, right now 3 square equal to 9 minus 3i square root of 3 to the second power. We need to raise each of these elements to the second power, so we need to raise 3 square times I square and times square root of 3 square equal to 3, yeah, and equal to 36. Okay, and the next thing we have 9 minus, with this minus because I square equal to minus 1, so we have plus 3 square, we have 9 times 3 equal to 36, and everything is great because we have 9 plus 9 times 3, we have 27 equal to 36. Yes, our root is absolutely correct. So I don't have enough space for this, so this is our answer. I just write it in this line. This is a quick check, so I really hope you understand it. I really hope you learn something new. A basic algebra question. So with the basic methods, we express one variable and we plug in it into a second equation. And here's once more, you can see a solution to this question. Also write your thoughts, write your response in the comments below. What do you think about this question? Let's discuss a little bit about this question in the comments below, and also write your thoughts, write your response. It's really interesting to see your questions in the comments below. So thank you everyone for your time. Take care of yourself and have a great day. See you in the next videos, and thank you everyone for watching my channel. Thank you everyone for watching my videos. I have we have more than like 600 video, I guess, on my YouTube channel. Different Math Olympiad questions, entrance examination, different great algebra Olympiad challenges. So I really hope you enjoy it. Also write your response in the comments below. What do you want to see on my YouTube channel? And it's also really interesting, and I'm really happy that I have that community. I'm really happy that I have that these people are here, so I really appreciate it, and I genuinely want to say thank you for watching my channel. So thank you for your time, take care of yourself, and have a great day. See you in the next videos.